All right, this is a calculation on chemical composition stoichiometry involving the purity of a sample. A sample of iron 2 sulfide, the formula is provided, FeS, is contaminated to the extent of 20%. What mass of this sample would contain 32.0 grams of iron? And we have relative atomic masses provided. So let us establish that there is difference between the sample and the vital component of it. So in this calculation, we should establish that the sample contains iron 2 sulfide, which in turn contains iron. The bulk of the sample is the whole bulk. This means it is 100% of the whole mass. Iron 2 sulfide is simply 80% because we have contamination of 20%. It is contaminated to the extent of 20%. So the impurities are 20%. That means it is 80% pure. How did we obtain the 80? 100% minus 20, which is for the impurity. So the iron 2 sulfide is actually 80% by mass and now contains iron. So let us establish a relationship between the molar mass of iron 2 sulfide and the relative atomic mass of iron. So our first move is to calculate the molar mass of iron 2 sulfide. Straight away into the solution, let's go. The solution. The molar mass of iron 2 sulfide, FeS. And that is relative atomic mass of iron given to us. It is 56 provided, plus relative atomic mass of sulfur provided, and that is 32. Upon addition, we're going to get 88 grams per mole, of course, the unit of molar mass. Now, very quickly, we like to mark here that out of 88 grams in 1 mole of iron 2 sulfide, 56 grams is contributed by iron. It is good to note that because that is a relationship already that we can take advantage of. This 56 is contributed by iron. Invariably, we're saying 56 grams of iron is present in 88 grams of iron 2 sulfide. That is a relationship. So we're going to use the dimension analysis technique. Let us start straight off from the provided mass. Therefore, we go 32.0 grams of iron. And now we're going to multiply in such a manner that the unit on the left is eliminated based on the relationship we can draw. Gram of iron must be in the denominator to cancel gram of iron here. So we take advantage of the relationship between the mass of iron and the molar mass of the compound given. 56 grams of iron, of course. 56 grams of iron present in 88 grams of iron 2 sulfide. And finally, we have to find a way to cancel out iron 2 sulfide as a unit here. And the way to go is simply in the denominator. The relationship now between the sample and iron 2 sulfide. Iron 2 sulfide, 80% as we established. The purity is 80%, since the contamination is to the extent of 20%. So 80% gram iron 2 sulfide, FeS. And now in 100% gram of the sample. And this is mission completed already because the gram of iron now cancels the gram of iron. Gram of iron 2 sulfide cancels the gram of iron 2 sulfide. And by taking the percentages off, there is percent here, of course, intended. We have the surviving unit is simply gram of sample. And now by using an electronic calculator to evaluate this, by multiplying and dividing appropriately, we're going to generate 62.9 grams of the sample. And this, of course, is our final answer. Very simple. And that is right there in the option B. Now, attached to this video are 2 quizzes which are provided to test your understanding of the content of this video. I recommend you take the quizzes, and of course, you can view the solutions provided. In addition to that, there is a link in the pinned comment that enables you to take a comprehensive test on chemical composition stoichiometry. This will help you establish your mastery or understanding of the topic. Finally, if you need to study the full topic, the analysis is provided in a link in the pinned comment. To study, learn, and enjoy. Thank you for being part of this session. And of course, I'll see you in my next video.